here, and this is part 2 of the inventory system. So if you've watched the first part, we went over essentially the data structure for the items themselves. So that's the things that are going to be stored within our inventory system. Since the last episode, what I have actually done is just imported some additional messages that we can use for the items. So these are just some of the primitive shapes. So we've got cone, cube, cylinder, and a sphere. These are just about approximately 20 centimeters by 20 centimeters. So there's nothing special about them. Just so we've got something we can use. So just so you can see what these look like, just place them in the level. So yeah, so these are just the primitives. They're just a bit smaller, so we don't have to worry about scaling down some of the bigger meshes. Okay, so I'm just going to delete those from the level again. Okay, so for this particular episode, what I was kind of thinking of kind of going over is more about using the item object that we've created, so the item base, and actually creating more of like a world item representation of that item base. So we can kind of utilize the item mesh that we have in that base class. So what I'm going to do is I'm actually going to delete some of the child classes of the item base. Just so there's not any confusion with what those are. So we've just got the pure item base. So just as a reminder, this is just what has some of the default variables in there. So we've got the item name, quantity, value, the icon, which potentially in the future will be for any UI displaying. And then we have the item mesh, that's what will be used in the world. So from here, I'm just going to go ahead and create a child of that base class. I'm just going to call it item primitive. And this is just going to be a bog standard base class that I'm going to use for the 4 other items, for the 4 primitives that we have. So item primitive cube, and I'm just going to duplicate these. And then we have cone, cube cone, let's duplicate that one again. Cylinder, and then lastly we have the sphere. Just like so, and then I'll just quickly pop in the name. So this one is the cone. So the item mesh, we'll go ahead and populate that as well. And then we have the cube. So again, just putting the item name in and selecting the mesh that will be used to display the item. Then we have cylinder. So, and then lastly we have the sphere. Just like so. Right, so now we've done that, we have these 4 base items that we can use for our items essentially. So what I'm going to go ahead and do now is actually go ahead and create a blueprint class, and this is going to be of type actor. And I'm going to call this BP_world item. Just like so. So this particular blueprint is what we would spawn in the world when we want to have a representation of one of those item objects that we have. And as a reminder, the reason why is because with us using a U object, they have no context to the world. They don't live in a world per se. They kind of live outside of it. So they're not capable of being able to have any static mesh components or anything like that in them, which in itself is a good thing if you just want a lot of data. But obviously, if you've got thousands of items stored in various inventories and things like that, we can't have an actor represent all of it, just because actors themselves can be quite heavy when you're using them just for data, so you want to use something more lightweight, which is why we've gone for the U object based item system. So the first thing we want to go ahead and do is actually go ahead and add a variable to this world item, and I'm just going to call this one item type. For this we're going to use the item base as the class reference. So we do want to make sure it is the class reference version. So that will allow us to effectively pick items from the list. Now, what may be worth doing as well, if you remember on the previous episode we spoke about the creating abstract classes. So I'm going to do that for the item base, and then for the item primitive I'm going to go ahead and do that as well. So there we go. So now we can only see in the list the ones that would actually be item representations. Okay. So with that done, we can on the construction script, what we want to do is we want to pull in this item class, also item type, and I want to convert that to a validated get. So this is essentially saying, does this have a valid reference set in it? So as long as it's not none, then it'll be valid, which is what we want to check. So if it's not valid, we probably don't necessarily need to do anything. But again, depending on the sort of game you're making, you might want to do something with it. It might be that you might want to destroy the world item, depending on the sort of thing you're doing. So moving on to the next section. So if it is valid, what we actually want to do is check another variable. So for this one, this is going to be the actual item object. And this needs to be of type item base, but this time it needs to be an object reference. So just as a reminder, when in terms of the class type, that you can think of that as kind of the instructions of how it would function, whereas the object is the actual thing that's being constructed from that set of instructions. So whilst we have the item class type here, we do need to actually construct the object, which is what we're going to do here in a second, and then store that particular reference. So if the item type is valid, we want to check, is the item object itself valid? And if it's not, so if it's not valid, we want to construct an item object from this using the item type class. And then once we've done that, we can go ahead and set the item object to the one we've just constructed. Now, if the item object itself is valid, you kind of got two choices here really. So let's see if I can do a demonstration. So if we was to place the item in the world, and I'm just going to quickly set the item object to instance editable and the item type variable to instance editable, that will just allow the variables to be visible when we place it in the world, and we can edit those. So at the moment the item type is essentially invalid, so there's no item object. But if we set that to cone, you should be able to see that it has actually constructed an item object of that cone type. Now, if I was to change that to cube, the item type, the item object itself is still the same one. It's still the cone one, which isn't obviously ideal. Now, we can just clear the item object itself, and it'll cause it to update and refresh itself. But that itself is not always ideal either. So what we can actually do is get the class of the item object and check to see if it's equal to the item type. So we do a branch, just like so. Now if it's not equal, then we can come back down here and do the item construct again. So what this will do is if I now change that from cube to cylinder, it'll automatically create a new item object that represents the new item class that we've selected. Now one thing just to be aware of, particularly with some of these, there might be a case where if in this particular system you might have it where you can possibly specify things like the quantity that gets placed into the item object when it's first constructed. For things such as that, just by checking the class here, you're not going to know whether or not the variables themselves are the same, so you may have to do additional checks if that's the sort of thing that you're wanting. Generally what we're doing here at this particular stage with us on the construction script is mainly applicable for when you're pre-placing items into the world for like more possibly like scripted environments where these items are always going to be at this specific spot. As we go through, we will add some elements to the world item as well that will be more specific for when you're spawning them dynamically. But we'll kind of get to that as we go through. So at this particular point, we've kind of got a good start here. So we are constructing that item object, so we're all good. So the only time that's not going to do that is if obviously the item type isn't valid. So if the item type is not valid, just thinking here, what we probably want to do, actually no. I was just thinking you may want to clear the item object if that's not valid. So if I set that to none, for example, it'll clear the item object. If we remove it and then we set it to none, it'll still maintain the item object that it was last created. Again, whether or not this is something that you want in yours can sort of vary. Because we will be spawning some of these dynamically, what we will potentially be doing is actually setting the item object itself as we spawn the world item. So because of that, we do want to go ahead and expose on spawn as well. In terms of clearing the item object, you might not always want to do that just from the item type itself, just because that could cause complications, because then you're having to do additional checks for that. Okay, so I'm just going to, as I mentioned, I'm just going to leave that the is not valid blank for now. Obviously we may come back to it later. So I'm just going to go ahead and select one of these options. So I'm going to start with the cube. So what we now want to do is actually have a mesh update based on the static mesh that we have specified in the item object itself. So there's kind of a few ways we can kind of like tackle this. What I'm going to do is I'm actually going to add a static mesh component to this. I'm just going to call this one item mesh. So I'm going to set that as the root of the world item blueprint itself. And the reason why is because there may be instances where we actually want these to be physics objects. And if the main physics object itself, like the root of it, isn't your mesh, you can get some weird behavior as it moves around. So making sure that that is the root can help solve a lot of those sort of problems you might encounter with physics objects that are actually children or child components within the overall blueprint itself. So with that done, we're just going to leave the static mesh as null, well empty, none as well for now. And then what we actually want to do from here, where we construct, we've got the item object, we want to get the item mesh. Now, if you remember, it is a soft reference. So what I'm going to go through next is kind of how we would load that specific mesh into memory so we can then use it to update the mesh. Now, if you've not used soft references before, this itself might be quite new, so I will try and explain it as best as possible for you. So the first thing we want to do with any soft reference is something called resolve. So resolve soft reference, and it'll look a little something like this. Now, if this particular static mesh is already loaded, this will be valid. So we can do it is valid. Like so. And if it is valid, we can just set the static mesh of our item mesh directly to this resolved variable here off of this node. Just like so. Now, if it's not valid, what we have to do is load the item mesh. Well, load that static mesh. Now, when it comes to loading something, we have to do so in the event graph. So the first thing you'd want to do is then add a custom event and do something like load item mesh, and then we'll add an input to that, and that's going to be of type static mesh. We want to make sure that's the soft object reference. So I'm going to name the soft ref. There we go. And then what we can do is we can pull from this and we can called the async load asset node. So what this will do, it'll go ahead and load this specific asset. When it's completed, so when it's finished loading the asset, it will fire on this pin here. Now, one thing just to be aware of, the async load asset node doesn't maintain any sort of class that was pumped into it. So the only thing we get is just an object reference out. So we have no way of knowing what this actually was in terms of, was it a static mesh, was it a skeletal mesh, or anything like that. And that's one of the reasons why you may find yourselves creating specific functions for loading specific types of assets. So in this case, we have one here that's load item mesh. So we know that when this is completed, that it's finished loading an item mesh, well, a static mesh that we're going to use for the item, essentially. So we know that this is going to be a static mesh. So there's kind of a few additional options we can do at this point. So what I'm actually going to do is let's come back to the construction script, and I'm going to pull from this here. Just get the item object. I'm just going to convert that to a validated get, just to make sure that we only actually ever attempt to set the static mesh if there is a valid item object. And I'm going to collapse this to a function, and I'm going to call this one update item mesh. So whenever we call this particular function, it will always check, is there a valid item object? If it's not valid, we can just set the item mesh to null, so that'll kind of clear it. If it is valid, we get the item mesh from it. We check to see when we resolved it, so is it loaded? If it is, we can go and set it. If not, we can then come in and call that load item mesh function, and we can pass in the item mesh soft reference. Just like so. Now, we just need to connect a target. There we go. Now, at the moment, when we actually go to load the item, we don't do anything. But because we know whenever this is called, it's because we're wanting to update the item mesh. When it's completed, we can just call the update item mesh again. Because when we load the asset, it's not going to instantly unload again. So when we call this function and we get to this resolve node here, this is going to be valid when it gets called again, because it's finished loading it, so it's going to resolve, so it'll automatically come through here. So this is a way that kind of saves us having to check, do a cast to static mesh, which sometimes you might have to do. Let's see if it's valid, and then set static mesh. So this is kind of like an alternative way of doing it. But personally, I'm not a big fan of doing it this particular way, because it kind of feels a little bit more messy to me, because we're kind of then setting the static mesh in from different places, and ideally you want to try and keep that as minimal as possible. Because that way, if you know there's ever an issue setting the item mesh, you know there's only really one place to look. So for me, I'm just going to call that update item mesh function again once the async load asset is finished. So that's, like I said, it's just going to go through, and it's just going to end up validating again. If in the update item mesh function you possibly end up doing some additional checks and things like that before you even get to setting the mesh, then you might want to use the other method that I showed here, because that way it kind of just saves you having to do those additional checks again when it's finished loading. But for what we're doing here, all we're doing at the moment is just pulling the item mesh from the item object, checking to see if it's loaded, and if it's not, then we take it to load. So there's not much going off there. So just calling the function is kind of like the easiest way to handle that. Now, in terms of having the item mesh loaded, that should be it. So what we can do, let's have a quick check to see if it does anything. And the answer is no. Okay. So why is that not doing anything? So let's have a quick look. So that's called on the construction script. Okay, yeah, so when we come in here on the item object where we check if it's valid, we then check to see if the classes are the same. Now if it is, we can come through and just update item mesh, like so, and there we go. So now what we can do is we can select the different items, and it'll automatically update the mesh based on the item object that we have selected. So far we've obviously got a few items we can copy and paste, move them around. If we play in the world, we can kind of see what they look like. Okay, so the next thing we want to do is just in regards to initializing some of those variables. So in the item base that I've set up here, I did add the quantity value. Now the quantity value itself is going to be how many of this specific item is represented in this given item object. So if you're not doing item stacking per se in the world, then you could probably skip this bit. But there may be times where you want to place something in the world previously and you want to denote the amount of items within it. So what we can do is go ahead and add a quantity value. If I spell it correctly. And we want to set that as a type of integer. And I'm going to go ahead and set that as instance editable again. So that way we can see the item quantity there. Now generally we always want to make sure that's going to be at least 1, so I'm going to set the default value to 1. Now the next thing we want to actually do is set the quantity in the item object. So you could come in here and do this set quantity like so, to the quantity specified, and that itself would it'd work perfectly fine. It would update the quantity inside the item object. Now that however is not always going to be a particularly good way to do it. So generally if there's going to be something that we update within the item object, we kind of want it to trigger event dispatchers, because in a lot of cases the data we update will most likely need to have some visual aspect updated somewhere, whether it's updating the mesh, could be updating some UI values, the name, text, that type of stuff. You know, depending on the sort of game you're making, you might have custom skins that you can apply to something, and the actual skin or the material that's applied is stored within the item object. So if that's ever updated, you need some sort of callback so you can do something else and kind of handle that updating automatically. So what I'm actually going to do is inside the item base, I'm going to go ahead and set the quantity variable to private. Now what setting something to private does is it prevents anything else from having access to it. So when we go back to the world item, we get this lovely error. It says the variable name is private, can't be accessed in this context. So you're probably thinking, well, if it's private, how are we going to update it? And it's a very good question. And simply put, we want to make some getter and setter functions for the quantity. So we'll start with the getter function, just because that's nice and simple. So we want to do get quantity. And we'll do a quick return on that function, just like so. And we can go ahead and just set that as pure as well. So now whenever we want to get the quantity, we can just use the getter function. The next one I want to do is set quantity. Now for the set quantity, it's kind of something similar. The only difference is this time we use a set node instead of the get. For the input value, I'll put new quantity value. I'll do that as a new amount just to make it clear. Okay, so if we go back to the world item, we can then pull from the item object and use the set quantity function. Just like so. So now it's set up so it functions exactly the same. Now the great thing about doing it this particular way is because it's now a function, whenever we update this particular value, we can have it do something for us. So in the item base itself, I'm going to go ahead and add we'll create an event dispatcher. And I'm going to call this one on quantity updated. So that's so, and then I'm going to add an input to that event dispatcher. I'm going to call that one new quantity. So that's so, and then we're going to go ahead and call that event dispatcher as soon as we set the quantity, just like so. So now whenever we set the quantity within an item object, it's going to call this event dispatcher. So let's say we have some UI elements that display these items, and as a part of that there's a text field that shows the quantity value. So we can then have it set up where those particular elements automatically bind to the item objects, specifically the onQuantityUpdate, and then whenever that gets called, it will automatically update its text. Doing it that way, it kind of allows you to be able to keep all that updating stuff inside the specific widget, because at this particular point only itself needs to know if it's updated, and that's just to update the text. Adding to that as well, I know certainly a lot of instances that I've seen, some people will opt for just refreshing the entire UI when anything changes, which again can be a perfectly valid option depending on what it is that you're doing. But you do just have to remember that if to initialize the UI itself, there's quite a lot of steps and calculations that have to happen. You would generally want to try and avoid doing a full refresh of your UI. So using event dispatchers just to update sort of changes in value, particularly if it's just for text, can be a great way of having to avoid doing that sort of stuff. So in terms of the setting the quantity, that itself should now be done. And you're probably thinking, well, how can we check? That's a very good question. So with these 3 items in the world, if we go ahead and actually play, and if we go to world item, we can choose the 3 actors that are in the world as our kind of like debug focus. And if we hover over one of these pins, we can see the amounts that are listed in there. So this one looks like it is the cube one. And if we do the world item 1, that is the cylinder, and at the moment they're all 1. So what I'm going to do now, I'm going to go in and just change some of these values. So for the sphere, we'll go ahead and set that to 8. The cube, we'll go for 6. And then for the cylinder, we'll go for 2. Now I'm going to go ahead and test again. And select one of them. And this is the cylinder. And you'll notice that the quantity is still 1 instead of the 3 value that we set. And that's going to be the same as all the others. So you're probably thinking, oh, have we done something wrong? And the answer is not per se. So the issue we've got here, as I mentioned earlier, is we've already got an item object and it's already valid. So at no point do we ever call this set quantity function. So you kind of have a choice here, really. What we can always do is, instead of having it called off this separate branch here, we kind of merge it together. So we separate the item object from there, and we have that also call the set quantity function as well. So now if we was to test again, so now the cylinder is showing us 2, the cube is showing us 6, and then the sphere is showing us 8. So as you can see there, all the items themselves are now updating that quantity value. So yeah, so at this particular stage, we are making some progress in terms of getting this inventory system up and running. So far what we've got is the item base object. That's essentially contains all the data pertaining to our item. We now have a world item, which is what's used to visually represent our item objects in the world when we need to. So I'm going to go ahead and leave it here for this particular episode. But for the next episode, what I'm thinking of going to going to go ahead and do is actually start work on the inventory system itself. So what we're going to do is when you overlap one of these items, it's then going to add it to an inventory and it's going to store those item objects somewhere. So I just want to say thanks again for watching, and as a reminder, I do have a Discord, so by all means, if you want to have a chat about something or you need some help, by all means jump on there. I myself, I do try and respond when I have a little bit of time. So stay tuned for the next episode, and thanks for watching. Enjoy the rest of your day and take care. Bye.